Well, hello, everybody. Welcome to another Create with Maxon with my two very good friends, Dominic and his mustache. They're both very close to my heart. How you doing, Dominic? How's your mustache?
Thanks, I'm doing great. My mustache also it's growing and growing. So perfect. Let's
I
start.
feel jealous. Now, what I'm going to do is I'm going to switch sides. So when I look at my monitor, it appears that I'm looking at you. Okay, is
Yeah,
that has
it's a
that
good
messed up?
idea. Yeah,
Has
yeah.
that messed up uh, your
No,
layout? No.
it's way better.
How are you doing? Is everything
Yeah,
good on your side?
great. Yeah. I'm totally excited.
So,
Uh,
for everyone that does not know Dominic, I'm going to go through the housekeeping quickly to get it out of the way. And then Dominic is going to tell us who he is, what he does, and what he's going to show us today. Hopefully, we're going to have a lot of people that are interested in this little presentation that's going to go on for the rest of January. So let me quickly switch over here and let's make my screen full screen. And I guess everyone can hear me because no one's complaining. And make sure if you want to, let me go and get this little link here and paste it in the chat, in the comments. If you want to go to this page, just use the link you will see in the chat. And I think I can bring it up as a banner as well, just in case not everyone has access to the chat replay. And just use this link to go to this page here, which has all the events, this university links, and all that. And of course, you can ask your questions for the Ask the Trainer show. Just fill in this form and you will go to pages like the Maxon events, which is always updated with the latest shows and live events that are going on. Make sure you go to the Maxon Training Team YouTube channel, where all these shows are hosted after being broadcast live, and with the addition of comments and timestamps, courtesy of our very good friend and mentor, Dr. Sassi. Of course, go to the Maxon VFX YouTube channel and check out amazing presentations and videos from a host of talented artists and various events around the world. Don't forget to go and learn ZBrush on the Max on ZBrush YouTube channel and just download the iPad version of the best sculpting software on the planet. And just do yourselves a favor and start sculpting from your couch. And of course, go to Cineversity and watch thousands, hundreds, I don't know, I don't even know. I think it's thousands of videos that have been made over the years. And yeah, we're still adding more. Having said that, again, this is the link that you can use. Let me do the following now. There we go. Oh, this is the wrong one. Yeah, I don't like the squares. That's better. So let me make sure I have the right. Let me go to the comments. I'm doing producing as well, so mistakes will happen. And yes, Dominic, who are you? What do you do? Where can people find you? And what are you going to show us today?
Yeah, thank you. Yeah, my name is Dominik Ruckli. I'm from Switzerland, from the heart of Switzerland. So I am a designer, motion designer, art director, and of course a big 3D nerd. So I think that's why I'm here. I have here a little studio in central Switzerland with some good friends. So we do mostly motion design, a lot of also film stuff, branding, design, installation stuff. So everything you can find in the central Switzerland. So yeah, that's what I do. I started using cinema it's a long time ago, so I'm a oldie, and maybe 20 years ago with R10. So I totally love cinema, but I was also I learned design, but was also very interested in technical stuff. So I also love to do stuff with electronics and programming stuff. And that's the reason why I'm here, because Maxon also added to cinema the new note system. So it's not super new now, but I think in this release there is a lot of new cool things, and this is what we're gonna do. We will Today we are working with the new Particle Nodes Modifier. So it's already written here. So in 2025.1, they added the new Particle Nodes Modifier to the new particle system. So, and let's go through here to show you what we're going to do. These are the topics. So the first thing, we're going to build a little sample texture modifier. This look a bit like this. Second, we will build a little field turbulence modifier, and we get at the end kind of a result as we have here in the title image here. And that's the thing. And then next we're going to do is a little exercise about the cross product. So don't be afraid. I think the cross product is something that you use a lot in when you work with nodes and with kind of the technical side of 3D. So I will go into this, and together with the cross product, we then going to build a flow field surface modifier. So to get patterns like this. And this is how it will look. And then we do a little additional exercise with this. Maybe we have time. Otherwise, we going to build some height fields. And out of these height fields, the last topic that we're gonna build is a little raindrops modifier with the particle nodes modifier. So maybe I have to jump one of the topics if you have enough time. We will see. But that's the end. And if you have some time at the end, here it is the setup. I will show you what I did with this particle nodes modifier, with the raindrops modifier. Also went into normal nodes and made this erosion field. So that's maybe something I can show at the end. So it's not something that we're going to build. So we keep it basic. And yeah, that's it.
One thing to note is that in the YouTube description text below the video, you will find a link to all the files that Dominik has very kindly and generously provided for everyone to download these setups. So it's not just about talking. Dominik puts his money where his mouth is, and he's actually giving out these files. And for that, everyone should be grateful, including myself. So the other thing I want to add to this before we start is that I'm in the process of recording tutorials for nodes. Sneak peek, boop. End of sneak peek, boop. So I'm in the process of doing that. And on air, unashamedly, I'm going to tell Dominik that I'm going to talk to him one of these days, because I need some guidance, not technical, but more, let's say, structural, because he's one of those people that has delved in this and made a lot of tutorials. I will need your help. And now that I made this public, you cannot say no. Exactly.
You get me. Okay, of course, I'm here to help. I like to help. That's also why I'm. Yeah, maybe that's one part that I forgot. So where you can find me, it's on the last page. Go down. So you can find me on YouTube, because I started some YouTube tutorials about seed nodes. That's actually the reason why I'm here. And then you, of course, find me on Instagram here with this name here, Real Ruckli. And all my files from all my tutorials you can download for free on Gumroad. So that's this one here.
Yeah, thank you so much. That's extremely generous. And yeah, without further ado, I'm going to switch to full screen and just show us your magic.
Yeah, let's go. Okay, the first thing we're gonna do is, as I said here, the sample texture modifier. So let's jump into Cinema. And the first thing, of course, when we work with particles, we have to add an emitter. So let's go to simulation, emitter, add a basic emitter. And then we can already add the particle nodes modifier that lives here under modifiers. And this is our new particle nodes modifier. So maybe first, before we dive in here to the particle nodes modifier, there is also something new in 2025.1, and this is for particles. This is the custom properties. So maybe let me explain what custom properties are. So when you think of an emitter, when we go to the scene settings, So I'm ready here. When you go to simulation particles, you can see you have here particle properties. These are the standard properties that every particle has, like age, color, velocity, so things that you already know. And then this here is this new field. This is called custom properties. And this is what we can add to particles. So we can, to every particle, we can add as many custom properties as we like, and then we can work with those. And additionally, maybe some of you already saw it when you on an emitter, or maybe let me bring up another modifier, or a collide modifier. You have this new tab here called output. So the modifiers and also emitters can add those custom properties. And we work now with the UV coordinate property here. So we add a custom property to our particles. So we can activate it, and now we have to specify this this property. So let's go back to the press Ctrl D, go back to the scene settings, and then here we can say add a custom property. And what we like to add is, as I already said here, is the UV coordinates. So I will explain it later. Let's add this one. Say UV. Of course, the name doesn't matter, so you can choose your own name. And then you have to specify the type, because UVW coordinates are with 3 components. So this is a vector. So a vector has 3 components. Go to type, select vector. And when you go back now to the emitter, you have here this little drop down. Now click on this, and you can see now you can choose here your custom property called UV. So now you think, okay, what is this UV property? So let me explain. Let's.
One thing I'd like to.
Yeah.
Sorry for the interruption. One thing I want to let everyone know is that currently the way to create custom attributes is not, what we consider Cinema 4D standard. It has a bit too many things and clicks you need to do. The developers are working on solutions, and I think in the near future they're going to provide a better way of creating these custom attributes, just to let people know that you can use them, but it may feel a bit odd using them currently, but we're on it. That's it.
Great. Okay, then maybe rotate here our emitter first, so we can have a look from above. So, and make some initial settings first. Maybe we use a shot here, then add some more particles, maybe 10,000, that's fine. And we also remove the speed. Let's press play. And now here are our particles, and now the particles already have this UV property. And when you think of a UV map, for example, when you go to a sphere and have a look at the UV, you can see the UV have this X coordinate and this Y coordinate. So this defines where every point of the mesh is living on this UV map here. And that is the same what the particles are doing here in our emitter. So we have here the X coordinate, X, and the Y coordinate. So for example, particles around here, they have the coordinate 0.1 and 0.1 in both, and maybe around here 0.9 and 0.9. So what we can do now with this, before we jump into the nodes modifier, we can use this custom property also in our texture. So let me show what I mean. So let's add the material to the particle group. So our particle has now a material. Let's dive into the material. And then when you type in, you can double click here into the node graph, and then the content browser pops up, and then we can type in data, and then we can see we have here user data, and what kind of user data we like is vector, because the UVW is a vector. So let's bring this in here. Then we can specify here our name. It's called UV. And this UV, that's a very nice little trick we can use inside of an image. So let's bring in an image. Let's go to the content browser. Maybe use this nice autumn picture here, those autumn leaves. And then we can plug in here our UV coordinate into the offset. When you like to expose those those values here, you can press Control and then press on this little circle here. And then we get here the offset exposed. And by feeding our UV coordinate here into the offset is now every particle goes over this texture and offsets it kind of, and you will see it when we start the redshift render view. It picks up the color of this image. Let me show this. Let's go to Redshift. Open the Redshift render view. I already did a test here. Let's press play. And you can see here now every particle picks up the right RGB value of this texture. So yeah, that's kind of a neat trick, and we don't need the Particle Node Modifier for this. But it would actually be great to see those colors, not just in the render view, to see them already here in the viewport. So that's where we can use now our Particle Node Modifier. So the modifier works as every modifier. You can add it to the particle group, and now this particle group is now acting together with the Particle Nodes Modifier. Maybe give it a name here. Texture, sampling, texture, yeah, doesn't matter. So now we see here the inside of the Particle Nodes Modifier, and you can already see we have here our standard properties, so position, velocity, color, and so on, so the standard properties of each particle. And how does this Particle Nodes Modifier work? You can think of for this node graph, for every particle, we have kind of one of those node graphs. So it runs, we have now, how many particles do we have? I think we have 10,000. So this node graphs runs like 10,000 times, so for every particle once. So we can proceed every particle one after each other. So that's great. So, and now because custom properties we don't have here in our where the standard inputs are, the standard properties, so we have to import it first. So double click here on the node graph and then just type in property, and here you already can see you have this get particle property, and then you have to specify it. First we have a mode here, and the mode is set to current. We also could set it to unique ID or to index if we like to explicit pick one particle and say from this particle I want this information, but we leave it here on current. So that means it takes the property of the current proceed particle. Then of course the name, that's what we already did. We called it UV. And then of course the data type, as we already said, it is a vector. So we can choose here the vector 64 for this. And now we have here again our UV value of each particle. So what we can do with this is we can use a shader node inside nodes. So let's double click here and type here sample shader, and there is a shader node called sample shader. And you already see this sample shader node has an input called UVW. So perfect, that's what we need. So we can plug here our custom property into the UV. And then of course we need also the image data. So here the color data. So we need another shader node. This is called image. Here is the image. And then here in the image we have the file. So we go back to the content browser, drag in here our file, and then bring the result here to the color, and then the color here to the output. And now let's check. I hope this is big enough here. You can see, let's make the particles a bit bigger here. You can see we have now the color data of our image. So maybe some of you already see it. The image is actually flipped. So we have to flip the image also in the Y direction. I'm not 100% sure why it is flipped, but this is a pretty simple fix. So here, when you have a vector property here, or a vector output or input, you can twirl this down here, and then you have here the individual components, and this is the Y component. And also on this side, we can now say, let's flip this Y component, and we can do this with an invert node. Let's search for invert.
To be technically accurate,
Yeah.
I was told that it's 1 minus the not in. Is that what invert is?
No, invert is when it's flipped. So you can use it also for Boolean values. So when true and false. So and invert is like when you have a 0 and 1 is like switch. So the other one is negate. So with negate you can make an 1 to -1, and invert is always from 0 to 1, and also 1 flips to 0, 0 flips to 1.
Okay, so there's something about. I need to check it out, but I think it could be 1 minus Y, so that it works with
so like that calculation behind it.
Exactly, but for a single tile like what you are doing, the invert would work fine. Now, just for people's information, the reason this is required is that Cinema 4D as an application uses a different UV coordinate system than because back then there was no standard, and UVs were all over the place. But because Redshift works with many other DCCs, Redshift follows the more common UV, and that's why the UV data you get from the Cinema 4D object requires you to invert the V. That's the reason. If it's not a bug, it's just that with right-handed and left-handed rotation coordinate systems and all that, there's no real standard, and it became standard after Cinema 4D had already established its own UV coordinates. So that said, please continue.
Thanks. So I learned also something. Yeah, that makes kind of sense. Yeah, cool. So okay, let's back on track here. So here we can. I already imported here the invert node, so we can plug in here the Y component to the input and the result back. Let's check again. And here we go. Now it is flipped, and we have our particles are now colored here with our image data and in the viewport. So, and of course here for this example, that's nice, yeah, but what we can actually use now here our color data to manipulate our particles. So that's the cool thing. So we can also twirl this down here, and then we see I have here the RGB values. So for example, for this example, we can maybe use the G value to manipulate the velocity. If we would say, okay, everywhere it is green, or maybe say red, because there is more red inside here. So let's say everywhere it is red, the particle move up in the Y direction. So because the velocity is a vector, we have to prepare a vector first. So you can do this with value. It is one solution. The value node is just like a constant value here. You can define here a value with different types and plug this out. But when we go to vector, we can also again open this here. Oh, this we don't have to open. Then take our red component, add it to the Y, and then to the velocity. And maybe let's check. You maybe can see it. They start to move up just a tiny bit. That's because the RGB values are normally just between 0 and 1, so it is not enough strength. So it would be great to have here on our texture sample modifier, because we build our own tool here, to have kind of a strength parameter. So that's, we have here our vector, our own velocity vector now. We like to scale this velocity vector. So we can do this with a node called scale. So as it says, it scales data types. So here we can say also vector. We plug in here our vector, and then we have here the input 1, and plug this here to the velocity. And now when you grab here the input 1 and release here on the nodes graph, then it asks here if you like to add a new input. So we create our own parameter with this. So let's release and maybe give it a name called strength. So it's my typing here, huh? Strength. Here we go. And now when you click on here our particle nodes modifier under inputs, we have now our own parameter. So maybe let's say 10. Let's check. And you can see the particles are moving depending on our red component of our image. And maybe just for finish here our little texture sample modifier, we can also multiply here or adding the age to our y component. So you will see what we get then. Let's make this. Let's use an add. So we like to our y component here, we like to add the age of the particle. And then again, because we like to have kind of a parameter to say how much of the age we like to add here. So you will see what we get then. So we also use a multiply. So we multiply the age first and then add it here to our y component. Then also make here a parameter and we call it speed, and you see why. Let's call it speed and maybe say just a tiny bit, maybe 0.1. Let's look from the top. And you can see we're shifting now with the age of the particles. We are shifting now here the y component. So yeah, and this is it for the first part here for our little texture sampling modifier. And I think in the next step, we like to go to our field turbulence modifier. But let's check if we have maybe some questions. Noseman, do we have?
Yeah, there was one main question that is general particles one. How do we emit from, let's say, the opaque parts of a texture? So how do we emit only for opaque texture pixels? I offered a suggestion where you can use a shader field and create a vertex map and use that to control either using a point selection, the emission, or to kill particles that are within the alpha channel. But you do need a dense mesh to do that. Whereas if you're going to use a texture, that is something that could be interesting to tell the particle nodes modifier, read the position of the particle up at its birth and check and see the UV coordinate at that point and check an image for that UV coordinate. And if the alpha channel is a certain value, you can kill it, something like that. It does need a setup, but it's something that you actually need to set up. There's no direct way of saying emit from this value, but you can emit everywhere and then check the particles to see what is there, if there's a pixel of a certain value and within a certain proximity. These are good questions to ask. And maybe they become tutorials because that is something that have been asked a few times. If you have a quicker answer or different answer.
I would definitely also go with this solution. So, but it's because our image here has no alpha value here. So, but for example, we could build kind of a threshold with one of those values. So if you want to say dark and bright, let's use maybe the green channel, and then we can build a condition and kill the particles that are not like reaching these conditions. So for example, when we say compare, so we can compare something, and we have here the operation of the compare. We say this is greater than, so we can maybe check like maybe use the blue. There's more blue than green in there. So, and then we can check, is the blue value greater, or we also can choose less than. Let's keep it to greater. Maybe say the middle 0.5. So colors are from 0 to 1. And then it's here this nice output. It's called killed particle. And you can see this is a Boolean value. So this is true or false. And also here, our result is also a Boolean value. So we can plug this in here. And let's check. Yeah, and you already see the particles get killed where it doesn't reach here this condition. So I think also this would be an easy fix for this. Yeah.
Fantastic.
Yeah. So I think let's go to the next one. So let's go back here to the presentation. So let's build this as I call it. Oops, sorry. As I call it, the field turbulence modifier. So we can actually use fields together with our particle nodes modifier to build this kind of structure. Maybe let's show a video here, small video, so you can see it. So it's actually a super simple setup. We can an impressive look like this. So here I emit from not from a plane, so from a actual geometry, but that's what we at the end get. So let's go back to Cinema. I think we can stay in here, so we can keep here our texture sampling modified. So we have the colors, maybe remove the kill part, maybe remove the speed and the strength. So we just have static particles like this. Okay. Then we need an additional particle nodes modifier. Let's go back here to modifiers, then particle nodes modifier, and let's call it maybe turbulence fields. And when we have a look here also at the inputs, we can see we have here, I have the normal properties here, and we also have here some field properties, so field value, field direction, field color. So maybe some of you already guessed it here on the particle nodes modifier. There is a tab called fields, so we can use all the nice fields to use the field information together with our particles. So let's build our own turbulence. So we use a random field. Oops, that's the wrong one. Let's use a random field. And here inside the particle nodes modifier, you can see those three little icons. So we can activate them all, and those three icons actually correspond to those three values. So this one is the field value. So when we think of our noise, let's maybe go to your view settings and show our noise. So we have here our noise. So the value here is just a value from 0 to 1. So the dark values is 0 and the bright values is 1. And then we also have let's bring this up here, the field color. This is actually a bit hidden, but there is in every noise, there is also color information. We use this afterwards here. And then of course the field direction, this is this one here. So, and the field direction works a bit like when we zoom in here, and let's use the doodle. So when we have here dark areas, the field direction is just a vector that goes from dark areas to the bright areas. So it will look in this part something like this. So we have those vectors here that we can use together with our particles. So delete the doodle. Then go back here, and then we have here the values. So we can, of course, plug in the field direction straight to the velocity. Maybe let's hide here the view plane again. Let's check what will happen. And you already can see they start to move, but again, we are a bit slow because the field direction is also, it's a normalized vector. It's just like also from 0 to 1. So we can also add some strength here, again, with the scaling. Let's use a scale node here. Switch it to vector. Add the field direction into here. Also, we can create a parameter, call it strength. And then maybe say 10. Let's press play. And you maybe can already see it. The particles are moving from the dark areas to the bright areas. So they get squeezed here together. So that's what the field direction is doing. But the cool thing here is also that we can also use the field color. So it's a bit hidden here, but we can use this instead of the field direction. So let's make this. Let's have a look. And you can see they start to move around according to our color. But because the color is from 0 to 1 and we want our particles to move in every direction.
Okay, let me stop you right there.
Yeah,
there was a question. So David McGee did ask, why are my particles moving up and to the right? So this is fantastic. David, did you see exactly what happened now? Dominik created some motion based on the value of the field, and they're going up and to the right. And that's exactly what I meant when I said the values are from 0 to 1. Pay attention. Dominik is going to show how to do the solution now. So, Dominik.
Yes. Correct. Yeah. And maybe again, because the color is from 0 to 1. There is in a color there's normally no negative value, but we want our particles to move in every direction. So that's why we have to remap this value. So that's something normally in nodes you use it a lot. So there is this handy node called range mapper. It's this one. So, and we like to remap the color, but because we actually use the color as a vector, so we can switch here the data type to vector, plug this here into the input, and then we can define the input and output. So our input values from the colors are from 0 to 1, but our output values we want like from -1 to 1. So we want all directions. So we can say here -1, -1, -1, and now plug this here into our scale, and you can see now we move in every direction. So that's great. And then of course you can, because we have now here our random field, you can use all the nice noise types here. So Perlin noise is the boring one, of course. I think maybe FBM looks pretty nice. So that's also what I used in my example. But yeah, play around with all the noises. You get pretty nice effects. Let's make it a bit bigger. And to end this, let's make some additional particles. Let's go to maybe 80,000. Zoom out. And let's press play. Oh, and maybe add some additional frames here. And you get all the nice movement of our fields here. And then just to end it, let's add some speed here again. So we have also a nice movement over the particles. And then we have this cool effect here where the color glides over the particles, and we have the nice movement of here our noise field from the noise type FBM. Yeah, I think that's it for this part. Are there some other questions, or should we move on?
No, there don't appear to be any questions.
Mm-hmm.
The one thing I wanted to say is that if you want to hack the -1 to 1 we did earlier, you can actually unclamp your field list and use a direction instead of color. Would that work, Dominik?
Again, you mean straight in here, right? Straight in the...
Yep, and just use direction instead of color that you used. You used color. use direction and just remap it and clamp it and remap it from -100 to 100. I think,
yeah. Instead of using like the scaling inside here, yeah, I think this is
even that you can
should
remove
work, yeah.
Anyway, just putting it out there for people to experiment.
Mm-hmm.
Yes, you can move ahead. Please go ahead.
Okay. Then maybe a little the scary part. So now it's not scary. It's more about the next step. It's all about the cross product. So it's something you will encounter a lot when you work with nodes, when you work with 3D and like programming stuff. So it already sounds crazy. So, but it is actually pretty easy to understand, and could be very useful. And that's why I made a little example for you. I built a little C nodes setup where I can explain the cross product. So let me open it. Where is it? Here it is. Let's go back to Cinema. And maybe before we start, how is the cross product node actually look like? So let's check this, say cross product. And you can see the cross product needs 2 input vectors and then spits out here the actual cross product of those 2 vectors. So then let me explain here. So a vector is nothing else than also kind of a direction in space. So we have here the vector 1, this one, and the vector 2, this one here. So maybe when we look from this direction here, when they overlap, you can see we can build kind of a plane for when we have 2 vectors. It doesn't matter where they are. So let me show here. Let's show the plane. You can see we have here a plane that is here, corresponding to those 2 vectors. We can rotate here our vector, and you can see there's all 2 vectors are always building a plane. And the cross product is nothing less than just a perpendicular vector to this plane. So let's add the cross product here. And you can see it is perpendicular to this plane. So maybe when we rotate those vectors, the cross product is always perpendicular here to this plane. So that's actually it. So you don't have to understand the math behind. I also don't understand the math behind. It's just simple to understand maybe when you can visualize it here as a plane. So, and now, how we can use this. So maybe let's hide this. So when we think here of a sphere, and the sphere of course has points, and every point has a normal. This is also a normal vector. So maybe let's show the normal. You can see the normals are also directions here on our surface for every point. So actually, when we hide the sphere and just show the normals are nothing else than just also like directions. So let's go back. And then now the magic begins when we say, okay, we have those normals and we add an additional vector for our cross product. In this example here, I add a cross vector of y plus 1. So let's show this one. So this is the second vector that we like to add to our cross product. And maybe some of you already guessed it. When we now show the cross product, so the green one, and look from top, we can see the cross product is aligning to the surface. Maybe remove the other 2. And you can see it goes around this our second vector here. So we can also add here, maybe add x1, and then it goes around the x direction. So that's pretty simple, but instead of using here a constant vector value, we can add noise. So let's add some noise, and instead of using this one, let's use noise. And at the moment it looks a bit messy, but when we add points, 60, you can see we get those nice flow fields on a surface. And that is what we can use inside of the velocity to build. Let me show a little video. to build those kind of cool curly motions on the surface. So yeah, that's it for the cross product. So now let's try to build this puppy. So let's make a new theme file. Are there questions, or should I move on? Or
No, everything is nice
it's
and
okay.
cool. People are happy.
Cool. Sounds great. So
Yeah. Everyone seems content. Let me just bring up a nice little comment here. Two of my favorite dudes. You have the coolest Kong. We have to do something like, hey, oh wait, I need to. Right, there you go. That's my kung fu.
Great. Okay, then yeah, what we need first, we start with a sphere. Let's keep it simple. Actually, this trick works on every surface, but we keep it simple and make a icosahedron, is it called, sphere here. So we have even points distributed over the surface.
Yep. Icosahedron means 20 sides in Greek. And of course, I'm Greek.
Oh,
so
really?
Yeah.
Oh, yeah.
Ikosi is 20. And edra, hedron, is a side.
Okay. Is it also because like the platonic here is because the icosa has exactly 20 sides here?
Yeah.
Okay, gotcha.
Yep. And platonic because of, I think it's Plato. So there you go.
Yeah.
Yeah, nice. Greeks are everywhere.
Yeah, they were super intelligent guys down there. Yeah.
We are, yeah.
Okay, and of course, what we need first is again particles. So, but this time we like to emit particles on the surface. So instead of the basic emitter, we use the mesh emitter. So again, we have here the mesh emitter. Oops, so what's this? Bring this down here. Then the sphere is already in there. And again, let's use shot, maybe 10,000, something like this. And also remove the speed, make them a bit bigger so everybody can see it better. Let's press play. Here we go. Now we have here our particles living on the surface. So, and now when you think back here of the cross product exercise that we did, so what we need first is our normal vectors from the sphere. So first, of course, let's add an additional particle modifier, particle nodes modifier. Let's call this maybe move on surface, something like this. Let's open it. And so what we need first is actually our normal value. And because at the moment, the particle nodes modifier doesn't know that there is a sphere. So we have to import the sphere also here into our node graph. So inside 2025.1, there are these new input types called the, is it called object child, right? Oops. It's called object child and object link. So the object child is actually when you like to import the child. So when the sphere is living here, so we could import the child here, but I think in this case, it makes more sense to use an object link. So this is this one, object link. And now on the particle nodes modifier, we get this field here on the inputs, we got this object link, and there we can plug in our sphere. And it lives here and also here as nodes. So when this is not here, you can also drag it here if you like to have it as a node, the input, and then open it here. And now you can see we have here all the information of our sphere. And with this sphere, we can work now together with the particles. So what we have to do first is we need the normal information. So let's zoom in. Let's make them bigger. Sorry, for about, maybe for this particle here, we need the normal information of this point, and this point, and interpolate, like we need the average normal for all those. So we need some information. So we need the information of the polygon where the particle is living, and then of course those three normal values. So yeah, you will see how we get this information. So there is a super handy node called It's called on surface. I always forget the names. Point, closest point, is it right? Closest, whoops, closest, yes, here, closest point on surface. So, and it does what it says. It searches from a position. Doesn't matter where the position is. It searches the closest point on the given surface. So we can plug in here our sphere surface here to the closest point node here to the geometry, and then we can use our particle position to search the closest point. So, and again, for this particle, of course, the closest point is where the particle is living because it's straight on the surface. But the closest point on surface not just gives us the closest point, it also gives us the information of the of the polygon itself. So when we right click here, then we can add outputs here, and we go to output, and then we have here polygon index. And those two informations, everything we need to search the average normal, for example, of this particle. So, and to search those information, we can use an, it is called interpolate. So interpolate the normals. So it's called mesh property interpolate. So we like to interpolate a property from our surface, here. And you can already see we need the geometry, so our sphere geometry, we need the polygon index and the position. This is all the information that we have. So, but before we plug it in here to the geometry, let's make sure that it doesn't matter which surface we have here, which geometry. So we always have point normals. So for this is also a handy node called, it's called create point normals. So with this one, we make sure it doesn't matter what kind of geometry we have there. There are always point normals. So we plug this in here, bring this in here, the polygon index and the position. Now everything comes together. And now we also have to specify on our mesh property interpolate what property from our mesh we like to interpolate. And this is here under type. And here we can find our normals. So now every particle has now here the information, like an interpolated information about the normal, about the closest normal. So when we go back here to this this particle here, so then we use the doodle here. So maybe this normal looks like this, this in this direction, and this in this direction, and then we have here kind of an average normal from those three normals. So let's check if this worked. So we can plug in the normal into the velocity. Let's go back. Let's remove the doodle. Let's zoom out. Maybe let's press play. And I think it's pretty slow. Again, let's scale the vector first. Here, scale it, switch it to vector, plug it in, and maybe let's say 10. Let's check. And you can see the particles are moving outwards along the normal that we found here with this little setup. So, and to finish it, it's actually pretty easy. Now it's the time for the cross product. So what we did here in this example, we also need a noise value to build our cross product. So when we bring in here our cross product here, so this is our first vector, and our second vector will be a noise value. So we can go again here to the Particle Node Modifier, go to fields, add a random field, and then again here we have always, don't forget to activate those icons here. So for this, let's activate all. You can use the field direction, plug it in here, and then the cross product into here. And so we can see it better. Of course, let's add a tracer. Go here to the MoGraph stuff here, add a tracer, bring it down here, and then maybe oops, sorry, like this. Let's zoom in and let's have a look. Yeah, particles are pretty big now. Make them smaller and make the tracer black so we can see it better. So you already can see we have these nice curly fields on the surface, and of course you can play with here our field. Maybe make it bigger here. So something like this, and of course instead of the field direction, you also can use the field color here. So let's check this. How this will look like. You can see they move now all in kind of a similar direction. And here again, we have to remap it as we did before. Use a range mapper, set it to vector, plug in the color. Then here -1, -1, and -1. Plug this in here. And now let's check. And we get those nice curly flow fields, or whatever you want to call it. Yeah, I think that's it for this part. Are there questions? How are we in time? Oh, we are already close. Huh?
Yeah, but we have a tradition of overrunning. If the host is up for the task, yeah, when we say we're on time, that means we have a 15-minute or a half an hour overrun. Great. So there are a couple of questions. I want to address very quickly this one. And why aren't my faces going upwards? Let me do this. Okay. From 3 Druid, how do you approach learning nodes? And I replied tongue-in-cheek with patience. What I want to say is that there are ways to use nodes on a more easy level. But whatever level you're going to use it, you require, there is a certain amount of knowledge that's required. So you can do simple, make modifiers with extrusions, insets, and all sorts of other things, and create a nice little modifier so you don't have to repeat modeling actions and so forth. That's all nice. You can use the Particle Node Modifier for particles just by using fields. What Dominik is showing here is an excellent example of using the data from fields, which we know how to use, and just the understanding of what a velocity is. And here's the tricky part. If you don't know for particles what a velocity represents, why is Dominik affecting the velocity instead of the position, for example, then you're still at that point where nodes is not quite there for you. There are certain things that are underlying knowledge which you need to comprehend and know about the general 3D within Cinema 4D or any other software, so that you can start wrangling the data, because using nodes is basically that. Mostly it's for wrangling data. So if you don't know what the data does or what it's supposed to do, it's very hard to put things together. Having said that, I want to make it clear that the tutorials I'm preparing, which hopefully we're going to have a batch by the end of January, is not going to be aimed at the more basic users. There's a lot of an amazing amount of stuff you can do in Cinema 4D using MoGraph, using the standard tools. Cinema 4D is an amazing piece of software and has dominated the motion graphics industry even before nodes was an afterthought, right? Before it was even conceived. We shouldn't forget about that. The first batch of tutorials are to address people with a fundamental knowledge that they can start putting things together, and that will help us get more feedback and get more people onboarded on the system. As we go ahead, and depending on the necessity and the needs of the users and the questions and all that, we're going to add more and more information, because again, it needs so much background, like the cross product, right? That's one of 1,000 things, mathematical constructs, which are extremely useful in order to make fantastic things like what Dominik is showing right in front of us. If you don't know what that simple mathematical node does, you don't need to know what the math is behind it, but the fact that when we talk about a cross product, that's what we are trying to find, an arrow that is perpendicular to another arrow, essentially. So the learning nodes has a lot to do with how much of the data structure of 3D in general anyone knows. There is still, if you go to my YouTube channel, YouTube at Noseman, you will see that I've made a video how to create a modeling modifier. That could be sort of the simple level you're going to use nodes, but I don't consider that nodes per se. It's just using the modeling tools of the nodes to do something very specific. And that was a long way to say that it needs patience, it needs a lot of reading, and a lot of trial and error. And I think that my question to Dominik is, because there's a question from Lisa here that says, are particles your speciality in cinema? What do you find the most challenging when working with particles and simulation, calculations, combination of vectors and hardware? And I want to add to that, what were your challenges when you were learning how to do nodes?
Yeah, it was. What should I say? I think it's good to have, as you said, you have this base knowledge of understanding the math behind it, and of course, it was at the start there was a bit a lack of resources, but I can actually recommend go and read the documentation. This is also when you try to learn a programming language, and I can also recommend the Core4D channel. Maybe I can put this in the chat afterwards. They start with super basic stuff, but at the end, it doesn't really matter where you learn this stuff. The concepts behind this is everywhere simple. So when you learn one programming language, so you can apply this to another. And here's pretty much the same, because what we do here with nodes is kind of visual programming. And if you learn maybe WOPs inside Houdini, or you learn geometry nodes inside Blender, all this knowledge applies. It's just like some concepts are a bit different, but the core of working with nodes and building like geometry from the ground up is everywhere the same. So yeah. So yeah, my main challenge is always to have enough power to box through all the stuff. So, but yeah, if you get at the end, it's if you all want to learn about textures, you also have to understand the physics behind light, how light reflects on a surface. If you want to make good textures, you have to understand the physics behind. And it's the same as here. If you want to make nice geometry, like from the ground up, it also applies in Houdini. If you want to make cool stuff there, you have to understand the fundamental of vector mathematics. So
yes, and matrices. I hate matrices.
Yeah, this is the worst. Yeah. But it's pretty much the same. You just have to know which tool you have to use where, but to understand the core behind a matrix, no way. Then you need a degree in computer science. I don't know. Yes.
What I'd like to say is, first of all, everyone say hello to our very good friend Jess. She did a series of amazing streams before last year, which was a few weeks ago. Go watch the replays. Do yourselves a favor. Hello and thanks for being with us, Jess. And hopefully we're going to see you soon on our show by popular demand. So yeah, please everyone say hi to our friend Jess, virtually visual. Now, the one thing I wanted, again, just Lisa's question, briefly, what is your main challenge when you work with particles and simulation? Do you have any challenges, specific or?
It's hard to say. So my main challenge is actually I know what I want to like to achieve, but then I have to figure out what nodes and which calculations I should actually use, which and there I also can say I could go to on ChatGPT and ask ChatGPT for maybe some rules if you want to understand what is it behind. So, but yeah, I think the main challenge is to not. First, to make a clear vision. So what you like to achieve, what is the final goal, and maybe make some notes and then split it into parts and try, as we did also here in this example. Says, okay, now I know I need the normal, I need a noise vector. So and at the end I like to scale this. So and you can split it apart and work step by step. So that's maybe a good thing to do. Yeah.
Excellent. Yeah. So please proceed. You have more stuff to show.
Yes. I think let's go back to the presentation. I think we jump one section. So let's go straight to the height field and then the raindrops modifier, because we are very close to this. So let's build those height fields. So this is actually pretty simple. So we can use here our setup that we have. So let's bring in a landscape. So here is our landscape. Let's make some space. We don't need the sphere anymore. Then go to the emitter, and inside the emission we add the landscape. And also here on our particle nodes modifier, we also add the landscape. So we have here in the object link the landscape information. And then instead of using here our field value, we delete this. And as we did in the cross product example, just add, we use here a constant value, and this will be the vector y. So a vector that points up in y. Let's check this. Whoops. Let's press play. And you can see we built this kind of height lines here, and then we can make it a bit smaller here. Let's jump in here. Let's say 50. Whoops, 50. Yeah, then we get those nice height lines. So that's it for the height lines. But now we are pretty close for the where is it? For the raindrops modifier here. So we can use our setup that we have to build this raindrop modifier. So, but let's make some adjustments. So we like to have, because it rains, so the rain starts from the sky. So we, instead of a mesh emitter, we use again a basic emitter. Let's bring this up, rotate down here. Let's make it bigger. And then let's make some settings, maybe 1000 here. Let's make it bigger. It's on here. Maybe we can switch here the particle group here. Bring this back so we can delete this one. Then remove the mesh emitter. And then because let's check here. We have here then our, oops, deactivate this. So, oh, actually, I made a mistake. Sorry, because we need two particle group. I deleted one, so that is a mistake. So we like to switch the group, because we like to switch the group from the rains to the raindrops that slides downhill. So let's add a group again. Then let's say this is here our rain group, and this is maybe our drops, something like this. Go back to the basic emitter, add the particle group rain here. Let's check, and now we have here our pretty rain. Maybe let's don't make it as toxic like this. Let's make it blue. Here we go. And now we have here our rain. So now we like to switch the particle when they collide here with our mountain here. So we can use where is it? The collision modifier for this. Bring this into the rain group. And then the collision modifier searches for all the geometry that has a collision tag on it. So we have to add a collision tag to the landscape. So let's go here to simulation, add a collider tag, and then inside the collision modifier, there is this checkbox called switch on contact. And then we can specify a target group. We add the particle drops here. So now let's check. We can actually activate this again, maybe deactivate the tracer. Let's press play, and I think this is not the best color. Maybe let's make the landscape dark so we can see it better here. So yeah, that's better. So another switch, and now, yeah, they go around here. That's the wrong direction. But what we can do now to finish this project, let's go back into the nodes modifier, and we have here our, maybe let's explain this. Let's make this so. Let's make it bigger here. Our particles. Let's zoom into one of the particles.
I think I know what you're going to do. You're going to use.
But maybe let's explain it first. So we have the normal direction here of our landscape. So this one, this looks in this direction. Then we added also here in the cross product this y direction. So this y direction up. So we get a cross product. Let's use green. That is following the surface, so it makes this swirly motion around the hill. So, but when we now make an additional cross product with the normal and our cross product here, so this will point downhill. So let's check. Now I'll use the second cross product. Plug in the normal and our first cross product. Plug this into the scale. Maybe activate the tracer again so we can see it better. Give the tracer a better color, also maybe something blue. Then zoom out to delete the doodle. And let's check. Let's press play. Oh, they're a bit big, but you can see they already start to slide down. Let's add some frames. Let's make them also, oops, where is it? The scale to 1. Let's check. You can see they start to slide down those slopes here and build those lines.
That's fantastic.
And, and I think that's it for our raindrops modifier. And yeah, sorry.
I have an announcement here. So here's some advice by a very, very special friend. He's one of the developers that's working on the particle system. My very good friend Basil. Happy New Year. So he's giving us some technical advice. By the way, if one's not interested in switching groups, so the method that Dominik used to switch groups on contact, you can use the collider output collided. So there's a custom property you can create. Different modifiers allow for a different property, and anything that collides allows collisions with simulation objects, like the collide modifier, allows you to set 1 when an object collides, so true. And that way you can use, instead of using a different group, you can use programming within the nodes particle nodes modifier and say that if a particle has value 1 on its collided custom attribute, then do this. If it doesn't, then do that. And that allows you to do whatever modifications you're going to do within the same particle group. Now, there are many reasons you would want or to do that or not, but it's up to you. And the second thing that Basil says is just make sure that the auto off in the custom property definition, there's a little auto switch for some of the custom attributes, which allow it to auto update. So if you're counting collisions, then that auto updates with every single new collision. If you turn that off, it will only register the first collision. So there are ways you can work around that. Let's see if we have any more questions. I just want to say a great thank you to Basil for his amazing work alongside all the other incredible developers at Maxon. So everyone, let's bow our heads and thank the developers for the amazing stuff they're doing for us. Let's see. Drake, how are you? Jonas isn't here, no. Yes, we don't run over schedule. We give a generous pour. I'm Greek, and I know it's always free pouring when we used to go out. There's no measuring cups in Greece. At least there weren't when I was there. Just to let you know. Yeah, Marco is here. Everyone is here. Where were you? Everyone from everywhere is here. So if anyone just popped in, welcome. You can watch the rerun on the Maxon Training Team YouTube channel. And yeah, please keep going, Dominik, because the stuff you're showing is absolutely amazing.
Cool. Yeah, we are actually close to the end. So I think just the last thing I like to show, maybe just for a little goodie, is we don't build this, but is because we have now the information of our particles, like writing down the slopes here. So I built a little setup. This is built with normal nodes, not with the Particle Node Modifier. Let me see, that builds those erosion maps. So I can show it here as a video. So you can see it starts to erode. So that was as a mountain actually would work. So it starts to rain, the rain brings down dust and everything, and then it starts to build those those nice creases here. So
okay, that is a perfect example of why you should use nodes and when. This is something that maybe we can pull off with some of the classic tools. Maybe it's going to be complicated. Using nodes, you can actually do that. I wouldn't say in a more easy way, but you can do it in a stable and more controllable way. Sometimes it's, I would say most times it's worth it if you know what you're trying to achieve. But what Dominik says is very important. You need to know what you're trying to do. And what I will add on top of that is pencil and paper. I believe that if you're trying to plan a node setup that does some generative thing, whatever that is, you need to use pencil and paper and sketch out the idea of what you're trying to do and how the data is going to flow. Keep going. That's very interesting.
Yeah, as you said, it's at the end it's a little engineering job, so it's good to plan your stuff out. So yeah, then another thing that I actually did then with this, maybe I can. It doesn't make a lot of sense if I go into how this capsule actually is built, but now because we have this dripping motion here, I also did this. So it was also just a test. So first I started to build those sweat drops here. So they dripping, and it's all the same concept with those two cross products. And then I also did it, then I meshed it. I also made some particles like they get here catched from our drops, and then they built this. Let me open it again so you can see it. So, and then they start to build this nice droplets here around. That's what I built then with this setup. So it's where you have a little nice nodes modifier where you can use this then in other setups. So that's the cool thing. So you build kind of a little tool that you can use in other use cases. Yeah. So yeah, I think that's actually it. So I think we're also good in time. So maybe there are some additional questions. So, but that's it from my side.
Yes, it's mostly compliments, as you would expect.
Thanks. Thanks, everybody.
So yeah, I mean, thank you, Dominic, because this is all amazing. And everyone, don't forget, we just completed a quarter of what Dominic is going to show us over the month of January, and by the end of the month, there will be a bit more tutorial information. So yeah, if anyone uses, my social is on Twitter X, I call it Twixer, at NodesmanGR. Let's see if I have the banner here. You can DM me with various questions about these things, and I do. I would like you to if you have questions about nodes and all that, not how do I do this and how do I do that. Some questions a bit more, let's say, of a smaller context, and that way I can adjust the information I get. I'm planning to put in the tutorials because it's not an easy subject, right? It has a huge amount of depth. Dominic understands what I'm talking about. What are you going to teach first and how you're going to formulate it? It's not a linear process when it comes to nodes. It's more of an octopus of information. So let us know. I would like to thank Dominic for this amazing presentation, and I think that as we move forward, we're going to see even more interesting stuff. And please let us know, or use the forum. I posted in the link. Let me post that one more time. To make sure, I need to find all my different screens here. Where are my screens? There we go. Let me grab this link here. I'm going to paste it in the chat comments. There we go. And you go to this page over here, and you go down here and you ask your question. It comes in a spreadsheet. And that is a spreadsheet we use for the Ask the Trainer. And if we find anything that's that makes sense for the streams we're doing this month, we're going to add it in there. And with that said, I would like to thank you, Dominic, first of all, and I will see you in a week's time. I want to thank every single one of you that stayed with us for this 1.5 hours. And hope to see you in a week's time. Everyone, Dominic, bye-bye.
Thank you. Bye-bye, everyone. Ciao.
I need to press the buttons now to close this. This is supposed to be behind the scenes, yeah, while everyone is watching. Yeah. Let's see if this works. There you go. Bye.